Hi, welcome back to our Algebra 1 series. On this video, we're going to talk about how to find the characteristics of quadratic functions, how to find the x-intercepts, the y-intercept, the vertex, and the axis of symmetry. So given a standard form quadratic trinomial, I'm going to factor this. So I'll factor that to get x minus 4 times x plus 2. Now what that tells me is when I solve this, right, when I set it equal to 0 and solve, I would get x equals 4 and x equals negative 2. And that's the first thing that I need to find. Those are my x-intercepts. So my parabola will cross the graph at negative 2 and positive 4. Okay, that's the first step to finding the vertex. Step 2 is identifying where the vertex should start. Well, the vertex of any parabola is right in the middle. So I can ask myself, what's right in the middle of negative 2 and positive 4? And one way I can do that is by counting all the spaces on the graph that are between my two dots and going halfway. Another way you can do that is by finding the average of the two numbers. So I could take 4 plus a negative 2 divide by 2, and I should get 1. And if I look in the graph, it looks like positive 1 is halfway between. Looks like 1 is halfway between my two dots. So I start with my x-coordinate of 1. Now to find the y-coordinate of my parabola's vertex, I need to take that 1 and I'm going to substitute that back into the original equation. Now you could put the 1 in for x in the very first original equation, or I've found that it's a little bit easier if you put it in the factored form. So 1 minus 4 times 1 plus 2. Well, 1 minus 4 is negative 3. 1 plus 2 is 3. And if I simplify that, I get a negative 9. So I have 1 comma negative 9. To find my axis of symmetry, I need to take the x-coordinate from the vertex, which is just a positive 1. So there's my axis of symmetry at 1. That seems to work out well. 1 comma negative 9. So here what we found is we found our axis of symmetry, our vertex, our two x-coordinates. The last thing you might be asked to find in an Algebra 1 class would be the y-intercept. Well, what's kind of nice about our quadratic trinomials is the y-intercept is always going to be, in standard form, that last number. So my graph will cross the y-axis at 0 comma negative 8. So I could even put a dot there. And that helps me out just a little bit when I'm trying to sketch this. Right, I know that it's going to go through negative 8, and then it's going to take a little bit steeper slope. something like that. All right, let's take another one here. Another example, I've got y equals x squared minus 10x plus 24. And when I factor that, I would get x minus 6 and x minus 4. All right, now, if I set that equal to 0, because that's what I'm looking for my x-intercepts, and solve, I would get x equals positive 6 and x equals positive 4. So let me put my x-intercepts at positive 4, positive 6. Now my vertex we know is halfway between 4 and 6. So if I want to know what's halfway between 4 and 6, that's going to be 5. But I should verify that algebraically. I'm going to take my two solutions, 4 and 6, I'll add them up and divide by 2. And I will get 5. Now the tough part is, how do you find the y coordinate? I'm going to take that same number 5, and I'm going to substitute that back into my factored form, and then I can simplify. So negative 1 times 1 is a negative 1. And then again, to find the axis of symmetry, just take your x-coordinate from the vertex, copy that right down. And if you were asked to find the y-intercept, that would be up at positive 24. The last number in my standard form is a positive 24. That's where my graph would cross the y-axis. So let me make my vertex at, 5, negative 1. And I'll do my best to graph a little bit of a parabola there. Not super precise, but that's not really what we're looking for in this video. I would encourage you to pause the video, get a piece of paper, and try to find your x-intercepts, your vertex, your axis of symmetry, and your y-intercept for these next two. So why don't you pause the video, try those, and then unpause to check your work. All right, so this would factor to x plus 6, x minus 2, which means that this would be x equals negative 6 and x equals positive 2. So my vertex, to find the x-coordinate, I need to take my two solutions, add them up, divide by 2, and I would get negative 2. All right, let's check that on my graph. Negative 6 and positive 2. Well, there's 8 spaces in between these. So halfway would be 4. 4 is right in the middle. 4 spaces away from either side. And that x value is at negative 2. So this negative 2 looks like it's right in the middle of my two x-intercepts. And to find the other half of the vertex, I need to take that negative 2 and I need to substitute that back in to my parentheses, my factored form of the original equation. All right, so negative 2 plus 6, well, that's a lot like 6 minus 2. That's just positive 4. 2 negatives minus 2 more negatives is 4 negatives. So what I have here is 4 times a negative 4. And I can't really graph that on my 10 by 10 paper here, but at least I know where it's at. The x-axis, or not the x-axis, the axis of symmetry, x equals, comes from my vertex, negative 2. And my y-intercept, if I wanted to know where the y-intercept is, I'll just look at this last number. It's a negative 12. And my last one, we should have had a factored form of x plus 3, x minus 3. Vertex should be at 0, comma, negative 9. My axis of symmetry is x equals 0. And my y-intercept turns out to be the same as the vertex at 0, comma, negative 9. Now, if I were to graph that, I would graph a point at positive 3, a point at negative 3, a point at 0, negative 9, and I would do my best to sketch at least a halfway decent graph. Does not need to be entirely perfect here, but just something that's pretty close. Close enough that you get the gist. Let me know what questions you've got.